right, here we go. I want to go over the graphing portion of the notes that we did yesterday, so make sure you got those ready to go. We're going to look at the function y equals b to the x. We could then also put an a in front of it, and that just transforms it. So we're going to look at treating f of x equals b to the x as our parent function, and then do those vertical stretches and shifts to the left, right, up, down, that type of thing. So, but we'll base all our graphs off y equals b to the x. If b is greater than 1, we went over this yesterday, that would be an exponential growth function. And when b is between 0 and 1, we have exponential decay. I'm not going to I'm just going to put a general sketch here. Generally speaking, the domain, again, that's the x's that you can plug in. You can plug in anything on these. So our graphs are going to go forever left and right, so it doesn't matter whether or not we have growth or decay. Domains are going to be all reals. They go forever left and right. The range is actually the same on both of them also. When the b's are under the constraints that I put up here. B in all of these is positive. So when you take a positive to whatever power, you never get a negative. And I can't get 0 either because I can't do a positive to some power and get 0. So what happens then is you get what's called an asymptote. And the asymptote is, in this case, is this line right here. I'm trying to go through the x-axis. It'll be right here. And what's special about an asymptote is your graph is going to approach it as it goes to infinity, either to the left or to the right. Horizontal asymptotes can actually be crossed, but if you cross it, you end up coming back towards it and gravitating towards it. Treat it like it's a magnet. So at the end of the day, way over to the right or way over to the left, depending on which function you're looking at, your graph is going to pull towards that magnet. Now, the asymptote in each of these is this horizontal line on the x-axis, which hopefully you know is y equals 0. The y-intercept on both of them, we can simply find by plugging in 0 for x. So if we plug in 0 for x, we're going to have b to the 0, and anything to the 0 is 1. So our y-intercept on both of these is 0, 1, 0, 1, and I'm just going to put a dot there at 0, 1 on both of them. And then the difference between these two, I said the ranges are the same. The difference between these two, a growth starts low. As I go left, it curves down towards this asymptote, and as I go right, it curves up. So that's exponential growth. If something is said to grow exponentially, it's curving up as you go to the right. And eventually, sometimes they don't curve as fast as this. You know, it might take a long time. Like if you left your money in the bank account and you're earning 0.25%, like some of you might be in your savings accounts, it's going to go slow, 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 slow. But if you leave it in there long enough, it's going to curve up and grow exponentially fast. At some point, it might be hundreds of years from now, but at some point, they're all going to look like the initial graph that I drew. The decay goes the other direction. The decay starts up high. As you go to the right, curves down to the asymptote. In this case, it does not cross the asymptote because you cannot get 0. So, what's the range? Well, both of these go up forever, but they don't go down forever. They, in fact, don't even reach 0. So we could say 0 is less than y. So y is greater than 0, right? Well, I can put it the other way. Well, y is greater than 0. That's one way to say it. Next year in pre-calc, you would say goes from 0 to infinity. And the fact that I have a parenthesis here, I think I mentioned earlier in the year, is the ways I have a parenthesis is it is can't be 0. If it could be 0, you would do bracket. Then that would say that 0 is included, but it can't be 0, so it's just parentheses. If you guys want to start writing them like this, I'm perfectly fine with that. But otherwise, we're doing either 0 is less than y or y is greater than 0, same thing. Okay, so that's the general exponential growth decay graphs. I want to kind of know how they're going to look before you get started on. So, example 7. Is it growth or is it decay? Well, first off, is it exponential? Yes, it is. And it's growth because b, which is 3, is greater than 1. Okay, 3 is greater than 1, so growth. And what we're going to do is just graph the parent function. The parent function I'm going to use is f of x equals 3 to the x. And then the rest of the stuff I'm just going to move left, right, up, down, vertically stretch, whatever, like we've done in the past. So I'm going to graph y equals 3 to the x, or I'm going to make a chart for that anyways. To do that, I'm simply going to go from -2 to 2 on my x's. So -2, -1, 0, plug those in. Find the f of x's or the y's. So if I plug in 2, that's 3 squared, which is 9. If I plug in 1, 3 to the first is 3. 3 to the 0 is 1. 3 to the -1, that's why we need to learn chapter 6 stuff, is 1/3. And 3 to the -2 is 1/9. So that would be what my parent function would look like. That would look like my upper left graph that we had there, an exponential growth curve. But let's go ahead and tweak it using the transformations. So what are my transformations? Well, I got to deal with this 2 out front. I got to deal with this -2 by the x. And I got to deal with the +1 at the end. The 2 out front, what does that do? That's a vertical stretch. And a vertical stretch affects the y coordinate. So I'm going to end up multiplying by 2 because of that vertical stretch. What does the -2 up here? I'll use that green. What is the -2 up there? So that was x -2. What does that do? Well, remember when it's right next to x like that, you actually got to do the opposite there. Because when I plug in x is 2, I'm supposed to get 9. So in order to get 9, what do I have to plug in now? I got to plug in 4. Because 4 minus 2 is 2. And that would give me the same thing. And 4 is 2 to the right. So I got to go 2 right. So I got to add 2 to my x's. We've done this before. And then finally I got that +1 at the end. That +1, that affects the y coordinate. Just going to add 1. So that's how I'm going to get my points. I'm going to perform those transformations and go ahead and put those points in. One thing to note is that my asymptote starts here. But you might apply a transformation that changes it. So what kind of transformation would change it? Well, let's see. If I move it right and left, that doesn't change it. And if I multiply by a number, that doesn't change it because this is where y equals 0, and 0 times anything keeps it at 0. So what changes it is this last number. That tells me that the asymptote gets moved up along with all the points. So the asymptote is not going to be at y equals 0 at the end of the day. It's going to be at y equals 1. So it's kind of, I would draw that asymptote in first. Say, hey, I know it starts at the x-axis, but is there anything that moves it up and down? And if so, draw it there. Then you know how to make your curve. Then you know where not to cross. Okay, I'm going to go ahead and fill in my chart here. If I add 2, I get 0, 1, 2, 3, 4. Multiply by 2. 2 ninths, 2 thirds, 2, 6, 18. Okay? Add 1. Well, that's 1 and 2 ninths. That's 1 and 2 thirds. 2 plus 1 is 3. 6 plus 1 is 7. 18 plus 1 is 19. Okay, so I just perform the transformations. That gives me the points that I want to plot and then draw the curve through there. So I need to plot 0, 1 and 2 ninths. That'll be something like that. 1, 1 and 2 thirds. A little bit higher. 2, 3. 2 right, 3 up. 3, 7. 3 right. 4, 5, 6, 7 up. And then if you get off your grid, I'm not going to graph 419 because that's off my graph. I've already got the idea. This thing's already bending way up like that. And then I just graph, put arrows on the ends. Arrows are important. That tells me that it goes on forever and ever and ever in both directions. And verifies that my domain is all reals. And my range is y is not greater than 0, because we moved up our asymptote, y is greater than 1. Okay, so be able to do a domain and range as well. Second one. This one, b is 0.5, and 0.5 is between 0 and 1, so that's decay. I'm going to do the same thing. I'm going to graph y equals 0.5 to the x. So I'm going to plug in -2, -1, 0, 1, 2. Again, you might want to look to see if there's anything that's going to move your asymptote. The asymptote starts here, but gets moved up because of the +3. So there's my asymptote right in there. Asymptote y equals 3. If I plug in -2 simply into the 0.5 to the x, I got to do a half to the, that can be a little tricky. What's a half squared? A half squared is a fourth. Move that up for a little bit. A half to the first is a half. A half to the 0 is 1. A half to the -1 flips it over. That's 2. A half to the -2 is actually 2 squared, 4. So there's my starter graph. And now I just have to simply use the +3, which would be to the y. And then there's another x minus 2 right here, so again, that's 2 right. So +2 here. All right, so I add 2 to my x's. 0, 1, 2, 3, 4. I add 3 to my y's. 4 plus 3 is 7. 5, 4, 3.5, 3.25. And then I plot those points. 0, 7, 1, 5, 2, 4, and you can see we are then moving to the asymptote. Draw it in. There you have it. Okay, domain, all reals. Range, y is greater than 3. So that includes the notes on the graphing. The assignment is right here.